Here we go, 4.4, graphing on a calculator the polynomials. So last year you became proficient at graphing parabolas by hand, and then this year we reviewed a little bit of graphing them on the calculator, but we didn't focus on it a ton because we also used transformations a little bit. So today is calculator heavy. So if you do not have a calculator, get an app on your phone. If you have an Apple, go to your app store and type in um, just a second, I forgot the name of it. Oh, Calculator 84. And if you have Android, type in Wabbit EMU and it should pop up. It'll look just like a graphing calculator that you've seen at school. I'm not going to go over this page. This page is to help you remember what we did, what we're going to do in this video. So before we do that, we're going to talk about some critical points, critical features. So critical meaning very, very, very important. We're going to define these terms. Now these terms tell us a lot about the polynomial and give us the information. And hopefully the polynomial is modeling a real life situation. So I don't know, this is an old movie, but there's an old movie called October Sky about these boys who do a lot of rocket work and eventually become use that as their job. But one thing that happens to them is they launch one of their rockets and the fire ranger gets really mad at them, thinking that they started a fire, which is a big deal because it costs lots of money, lots of resources. But they were able to model the path and figure out that it wasn't even anywhere near the fire, and they modeled the path and went to location, found the rocket. They had proof that they did not cause the fire, so they were able to use the zeros, the maximum, and the domain and range to find that out. So pretty cool how you can use this. So zeros. Zeros are basically these points right here. So it's basically our x-intercept. You can think of it like that. So it's basically what x values will make y 0. So kind of like the x-intercept, the values. Minimum, so that is the lowest y value or lowest output that will be produced. And then maximum is obviously the highest y value. So they used the maximum, the y value to tell them how high it went, right, if they could find that value. Y-intercept will be, of course, what is y when x is 0. Okay, so maybe we intercept right here. So when x is 0, what's the y value? So when our input's 0. So for financial reasons, that's really good. You can see where you're starting out on day 0, right? So if your company, you're modeling it, you can see where you begin. Okay, whatever. Domain is all the x values, and range is all the y values. Domain's important. For example, if we have the function y equals square root of x, we cannot put anything we want into x. There's some restrictions there, right? You can't take the square root of a negative number, so x can never become negative. So the domain would be only use numbers from 0 to positive infinity. So 1, 1 million, 99, 64, all those numbers are between 0 and infinity, so the domain is restricted, and we show it like that. And the range will be all the possible outcomes, which is, like I said, the y values. So we're going to use our calculator to find these critical points using this model. Now I have a typo right here. This should be a negative. Now you have the picture over there in case you don't have a graphing calculator right now, but you'll really want one for the homework. It'll be very, very helpful. Or you can use Desmos also if you're familiar with that. Okay, so we're going to type that into our calculator. So let me pull this up. And I have an Apple, so this is the calculator 84. If you're using your normal calculator, it's just like that. All right, so here's our blank screen. Step 1, hit y equals. So basically the top rows are all the graphing buttons. And that's kind of what you're going to use right here. So we hit y equals, we're going to type it in. So just right next to the green alpha button, I hit my x, make it cubed. Now I'm going to get out of my exponent, plus x squared. And then let me remember what it was. Minus 8x minus 8 So type that in and I'm going to hit graph. Now you're going to see this looks just like the one on the paper, but yours might not. So let me show you. Something you can do is zoom 6 will take you back to a normal window, but I want to see a little bit lower. So I could zoom out if I wanted to. So zoom as you look. There you can see, you can zoom to a quadrant, you can zoom to a fraction of it, right? So zoom square, zoom decimal, zoom in, zoom out, zoom standard. Zoom's really helpful. The other really helpful button is window. So if you notice my Y's, I couldn't see the bottom, the minimum of that turn. So I'm going to type in -20. Okay, so X min, farthest left, X max, farthest right. The scale, I only want it to go by ones. Y min, get it clear down to -20, up to 10. Leave everything else the same and hit graph. Great, now I can see the main parts of the graph. And then I know that it's going up and down forever because if you remember from 4.1, we learned that the maximum number of terms that this can have is the degree minus 1. The degree was 3, 3 minus 1, 2. So I know these are the only terms that will happen, and then I know the end behavior is going on. Okay? All right, so if you remember, the first thing that I want is the zeros. So your calculator might be a little bit more precise at showing these numbers. It looks like I'm getting a 0 right before -3, if you look there. But something that we can do is we can actually find those zeros. So I hit the blue button, second, and then if you look above the button trace, it says calculate. So I hit second, trace. Well, here I am at there. And I want to find the zeros. Okay, and if you notice at the bottom of that turn, you're going to see it. And if you look up at the top, it says left bound. So I'm going to make sure I'm left of the 0. I'm going to hit enter, and then it wants me to be right bound. And then, oops, I hit too many buttons, sorry. Second trace, 0, left bound, right bound. Oh, I didn't go far, sorry, I'm not going far enough right. So left bound again, right bound. Oh, sorry, I'm not used to this. So if you look down at the bottom, it tells me that the 0 is at 3.53809. So if you look bottom left of this screen, 3.5, we're going to round it there, 3.5. Okay? Let's write that down real quick. 3.5. Okay, so we have a 0, x first, 3.50. And we're going to use the calculator to find the rest because, I mean, they're not very nice points, right? And I am rounding. Notice that. Okay, second trace, 0. I got to go left bound. And you just hit left and right to go where you want to. Left, enter, right, enter, -0.5. Great. And I'm going to find the other one while I'm here. Just don't forget -0.5. Okay, so I need to go left bound. Remember up at the top, it's going to tell you what to do. Right bound, boom, -2.2. Okay. So -0.50, -2.20. So those x values created the y value of 0. Okay, so minimum. We're going to look right there. Where does this drop down? What's that point? Okay, we're also going to find the maximum while we're at it. So we go to our calculator, second trace, minimum. And up at the top it says left bound, boom, right bound, boom. It says my minimum is at. Now you notice it's going to tell you the y value this time. So it says the minimum is at 2.04 and the y value is -11.5, right? 2.04. So I'm not used to this calculator, so give me 1 second. Oh, sorry. Duh. It's down at the bottom. If you look there, it's going to tell you the y value is negative 14.5. Okay. All right. Okay. Let's find the max and write that down on your notes. Okay. Enter, right bound, enter. Oops. Okay. So I accidentally hit the wrong button. So second trace, maximum, right bound. Okay, so negative 1.35, and then it looks like the y value is 4, right? Okay, so I'm going to write that down. I already forgot what they were. I'm sorry. But negative, what did we say? 1.5 and 4, and I can't remember exactly what that one was. But hopefully those are still on your calculator. Okay, now y-intercept, we can look here and guess, but we can also go to our calculator again. So we can make an estimate, or we can go to our calculator. Second trace, we're going to find a value. So it says, what x value are you looking for? Looking for when x is 0 or y is negative 0.8. Now when it says value, it only accepts x's, right? So you can only plug in x's and then find out what the y value is. So that's pretty cool. Wrong thing. All right, and what's the last thing that we need to do? Domain and range. So domain and range, you can use your calculator, or you can kind of do it by hand. I prefer doing it by hand. But let me show you. Second table. I hit second graph to get here. You're going to see that this is going on forever in both ways. Okay? I mean, it's just their numbers are always there. Now let me show you compared to this. I'm going to put in real quick a square root of x. Okay, and then I'm going to go to that second graph, and you're going to see that the y values have an error. They're not there, right? So we know that for our x's, we can, and our y's, we're not going to get anything below 0, right? So 0, 0 is kind of the end. All right, so min, sorry I'm not writing them down. Hopefully they're on your calculator. Max, y-intercept, I do remember that one. X was 0, y was negative 8. Domain, I want you to think eventually this is going to go down and left forever. This is going to go up and left forever. So our x's are going left and right forever. Our y's are going up and down forever. So we can write our domain and range like that. All right, so really this is just using the calculator to find out these things. So type these into your calculator, follow the instructions on the previous page, and then if you have any questions, let me know.